All right, in this lesson video, we're going to cover lesson 6.3 or day 6.3, and we're going to be talking about circles, angles, and arcs again, okay? Going back to 6.1, we've actually covered half this lesson already. We've talked about central angles and inscribed angles, so we're going to review that. But then we're also going to talk about two new kinds of angles that could form these arcs and the relationships of those circle to arc relationships, okay? So first we have central angles, and we talked about this in lesson 6.1. Central angles have a vertex at the center or middle of the circle, and the angle and arc are equal in measure. Okay, so we have the formula angle equals arc. Okay, when we have a central angle like this, angle equals arc. All right. Inscribed angles, again, we talked about these in the last unit also. Inscribed angles have a vertex that is on the circumference of the circle. So it's somewhere on the circle. So instead of being at the center, that's no longer the vertex of the circle. Now our vertex is on the circle. And that relationship is that the angle is half of the arc. Okay, so if this is x, this is 1/2 x. Okay, angle is half of the arc. So those are our two angle to arc relationships we've already talked about. But now we have two other kinds of angles we're going to look at. One is called an interior angle. An interior angle, the word interior means inside of, an interior angle is formed when two chords intersect. So they don't have to be diameters. So it's not necessarily a central angle, but it's where I have two chords that intersect. Something like this. Okay, so the center of my circle is still maybe a point there, but now I have these two angles, or sorry, these two chords creating angles. And it actually creates four different angles. But we're going to focus maybe on this one. And the relationship of that angle to the arc is actually dependent on two arcs. We have an arc over here that is created, but then there's this backside arc that also goes with that because this angle is also x, because they're vertical angles, right? So there's two arcs we're going to look at for interior angles. Because these chords intersect, it kind of creates this front side and back side arc. And that relationship is that the angle is half of arc plus arc. Okay, we're going to add the two arcs and divide by 2. All you're really doing is finding the average of the arcs. Okay, when you add two things and divide by 2, that's finding the average. Half of means divided by 2. So the formula here is half of arc times arc equals angle. And those are your interior angles. Okay, and then finally we have what's called exterior angles. In your exterior angles, it's very similar to what we just had, but this time an exterior angle is formed when two secants or tangents intersect. Now this could look a lot of different ways. I'm just going to show you one picture. The most basic picture is when I have two secants like this that intersect. Once again, they create two arcs. You've got this far side arc, the bigger one, and this closer arc, the smaller one, and then you have the angle, x. Okay, that angle on the outside of the circle, okay, exterior means outside, is going to be equal to half of the far arc, or the bigger one, minus the closer arc. Okay, so that is your relationship for these kind of angles. Now this is going to be kind of tricky until we start to get more practice at this. It'll make a lot more sense as we practice doing this, okay? But this is really important. We're going to use these four equations to solve problems. So let's go ahead and take a look at some examples. The first thing we always want to do is identify what type of angle we are looking at. Where's the vertex of the angles we're looking at? Okay, so on number 1, we've got some kind of competing information to make this a little more tricky. But look at what we're trying to find. We're trying to find the measure of arc FA and the measure of arc HA. I'll use two different colors. So for arc FA, there's a lot we could do, but what I want you to notice is the only given information we have is that angle measure. So that comes from this angle. That is what we call an inscribed angle because the vertex H is on the circle. It's on the circumference of the circle. So that angle to arc relationship, let me write that in, inscribed. Okay? That angle to arc relationship is that angle equals half of arc. You'll remember that from lesson 6.1 and today's lesson. So the angle, 56, is half of the arc FA. Okay, so we just multiply 56 by 2 to get the arc FA. So the measure of arc FA is 2 times 56, or 112 degrees. Okay? So now as we move forward and look at HA, the measure of arc HA, okay, I need some more information for this. The measure of arc HA is what's left if I think of this as a semicircle, because there's the center of the circle. That means FH is a diameter creating a semicircle. Well, I already know from my first part of the problem that this is 112 degrees. So to find the measure of arc HA, we're going to do 180 minus that 112. And if I do 180 minus 112, I get 68 degrees. Okay, so there's often more than one part to our problem. Let's try number 2. Okay, this is a new type of angle. These angles, or this angle, 121 degrees, is formed by two intersecting chords. Okay, that point is inside the circle. The vertex of that angle is inside the circle, but it's not the center. So we call that an interior angle. Okay, it's an interior angle formed by two chords. In that case, okay, interior angles, the formula we're going to use is angle equals half of arc plus arc. There's these two opposite arcs that we're going to use. Okay. So it really helps if you kind of focus on the angle that we're using and trace the arcs that we're using to go with it. Okay. All of these should kind of line up in a line. The arcs and the angles all line up in a line. So we're using angle equals half of arc plus arc. Well, the angle they give you is 121. One of the arcs they give you is 17x minus 1. The other arc they give you is 64x. And now it's simply a matter of solving the equation. So the first thing you want to do is simplify everything in the parentheses. 17x plus 64x is 81. And then I have my minus 1. Now I could do half of each of those, but those are both odd numbers, so that's going to give me a decimal. So rather than do half of each of those, I'm going to multiply both sides by 2 to cancel that 1/2. So this is 242 now equals 81x minus 1. Add 1 to both sides. Gives us 243 equals 81x. Divide by 81, and x is 3. But they want the measure of arc dj, so I'm going to plug in here. I'm going to do 17 times 3 minus 1. That gives me exactly 50 degrees. Okay? So again, let's move on and identify the angle we're using. In this case, look where the vertex of the angle is. They point to the angle. They point to this angle here. The vertex K is on the circle. That makes it still what we call an inscribed angle. The vertex is still on the circle. Now, this is a little different than some of the other inscribed angles we've done because part of the angle is formed by a tangent outside of the circle, but the vertex is still on the circle. So we're still using angle equals half of arc. Okay, we're still using that. The angle is this expression here, -4 plus 11x. That is equal to half of the arc. The arc that is created is where the circle intersects the angle. There, and then the vertex is the other point. So that 80-degree angle is that arc. Now, sometimes I don't give you this. Sometimes I give you the rest of this. But we still have to do the problem. Remember, a circle is a full 360 degrees. So to do that, we would do 360 minus whatever the major arc is to get this arc here, okay? So I just wanted to point that out. This example doesn't look like that, but others might. So this is my angle, or my arc, that is twice as much as that angle. Now I can do half of 80, that's easy to do. So my angle, -4 plus 11x, equals 40 degrees. So let's go ahead and solve. We're gonna add 4 to both sides to cancel that. 11x is 44, so if you divide by 11, x is 4. And that's all we had to find in this case. If I go too fast, again, pause the video to make sure you're catching this. All right, so number 4 here. We're given an angle that is outside of the circle. That outside word tells you this is an exterior angle. Okay, now remember from that previous page, the formula for exterior angles is angle equals half of far arc minus close arc, okay? And so the far arc is always the bigger one. Okay, there's your far arc. Now this time, one of these lines is a tangent. Okay, it's still gonna help you kind of set up these two arcs. That 81 is your near arc, or your close arc. Okay, far arc minus close arc. Okay, so the angle is 21x plus 5. It is equal to half of the far arc. There's your far arc, 73x minus 2. You have to be careful with this next part. We're going to subtract the close arc, 81. So sometimes you have to distribute a minus in this case. So be careful how we do that. In this case, it's just minus 81. So we're going to start to simplify. 21x plus 5 equals 1/2. I've still got my 73x, but minus 2 minus 81, those combine to be minus 83. Okay, they're two negatives. It's like you're adding two negatives. Sorry, adding two negatives to get a bigger negative. Now again, I don't want to do half of those odd numbers. It gives me decimals. So instead of that, multiply both sides by 2 so that we cancel that 1/2. So on this side, I distribute 2 to both of those. I'm running out of room. That gives me 42x plus 5 equals 73x minus 83. And now I can start to work with these numbers. I'm going to subtract the 42 from both sides because it's the smaller one. That gives me 31x on this side. Then I'm going to add 83 to both sides. Okay, 5 plus 83 is 88x. All right. I'm sorry, I just noticed a mistake. All right, I'm gonna leave this in here. I won't edit this out. I noticed my mistake. I'm looking ahead to the numbers, realizing that's not right. You may have already caught it. Let me go back here. When I do 21 times 2, I get 42, but I forgot to do 2 times 5 and make that 10. So that is going to fix that. Okay, that's 10. So when I add 83 to 10, I get 93, which will divide evenly by 31. Okay, I was looking at that thinking I'm going to get a decimal. That's not right. Okay, so this time x should be 3. Okay, but they want the measure of arc TS. Now that's tricky. TS is this arc. So remember, all 3 of these arcs, I've kind of colored them in purple, blue, and red. All 3 of those add up to 360. So a measure of arc TS is going to be 360 minus my 81 for the little arc, and then also minus this arc, which is 73 times 3 minus 2, which is 217. Okay, so I'm going to either add these together and then subtract from 360 or subtract them separately like that. If I add them together first, I get 298. So I'm going to do 360 minus 298, and I get 62 degrees. So the measure of arc TS, 62 degrees. Okay? All right, let's keep going. Again, on this one, we've got chords intersecting inside the circle. That puts that vertex in the interior of the circle, but not at the center. So it's not central, but it is an interior angle. Okay, so again, look back if you need to, but the formula for interior angles is angle equals half of arc plus arc. Okay, so this is one of my arcs. This is my other arc. Again, they all kind of line up for you. Those are the things that go together. This is your angle. These are your 2 arcs. So I fill that in. 23x plus 5 equals 1/2. One of the arcs is -5 plus 39x. The other arc is 50. Remember, we're adding arcs this time. Inside the circle, you add. Outside the circle, you subtract. So we start combining like terms. 23x plus 5 equals 1/2. -5 plus 50 is 45, but I'm going to write my 39x first. Again, I've got odd numbers. I don't want to do half of the odd numbers. I don't want to distribute a 1/2. I want to multiply both sides by 2 so that it cancels the 1/2. So this side is 46x plus 10. I remembered to distribute that time, equals 39x plus 45. Okay, so we're going to subtract the 39x from both sides. 46 minus 39 is 7x. And then we subtract the 10 from both sides. So 7x is 35. Divide by 7, and x is 5. This time they ask you for the measure of angle LMK. So we're going to trace that. I want you to be very careful. LMK is just that angle. Okay, they might ask for different angles sometimes, so be careful. So if I plug in 5 there, it's 23 times 5 plus a 5. Which gives me 120 degrees when I put it in the calculator. Okay? All right. We're going to go ahead and take a look at 6. I want you to look at that for a second. See if you can figure out what kind of angle it is. Is it a central angle, an interior angle, an inscribed angle, or an exterior angle? Okay, if you need to look back and compare it to any others, you can. But I want you to recognize the vertex of this angle, K, is on the circle. That makes it an inscribed angle. Okay, since it's an inscribed angle, angle equals half of arc. However, this angle is half of this arc, JK. I am only given the major arc. Okay, so to come up with an expression for this arc, we're going to take 360 and subtract the major arc. Okay, so this gets kind of tricky and difficult to think of. I've put parentheses here for a reason. Since I don't know what x is yet, I have to use this expression for this arc. But I can simplify it a little bit. So first, I'm just going to write this angle equals half of 360 minus 27x plus 16. Okay? However, this minus gets distributed to both of these. So those both end up being minuses. So let's rewrite that. 2x plus 17 equals 1/2 360 minus 27x minus 16. Okay, because you're subtracting everything inside that angle expression. And now we can combine some like terms. 2x plus 17 equals 1/2. 360 minus 16 is 344 minus 27x. Now I could do half of those, but again, that 27 is odd, so I don't want to do that. So I'm going to multiply both sides by 2. And I get this equation. I'm going to jump down here. 4x plus 34 equals 344 minus 27x. So what I would do is add the 27x to both sides. And then we can even subtract the 34 like this. 4 plus 27 is 31x. 344 minus 34 is 310. Even though the numbers are bigger, it still works out. X is just 10. So then they ask you for the measure of arc KJ. That's this arc here. Okay, so we're going to plug in 10 for X into that expression. Okay, so I can even do this with the parentheses first. 27 times 10 is 270. Then I add the 16 to it. So I'm going to do 270 plus 16 is 286. So I'm going to do 360 minus 286. What this tells me is this major arc all the way around is 286. So I'm going to do 360 minus that. And I get 74 degrees. Okay, so these problems involve a lot of work sometimes. All right, a couple more examples. So we've got our angle here. This one's going to be a whole lot easier. This angle has a vertex K on the circle. Very simple, formed by two chords, but the vertex is on the circle. That makes it an inscribed angle. All right, that angle is half of the arc. Okay, the angle in question is our question mark. That's half of the arc, 176. So all I have to do is divide 176 by 2. So this angle K is 88 degrees. All right, one last example. Okay, we have a vertex of our angle at C. It's outside the circle. Okay, angle ACL is in the exterior, so this is an exterior angle. And that formula is angle equals half of far arc minus close arc. Okay, the far arc is 15x minus 10. The close arc is 48. And this is your angle. So let's start to fill that in. 4x plus 6 equals half of 15x minus 10 for the far arc minus 48. And then we start to simplify. 4x plus 6 equals 1/2 15x minus 58. Again, I don't want to do half of 15 and get a decimal, so I'm going to multiply both sides by 2. Don't forget to distribute like I did the first time I did this. 2 times 4x is 8x. 2 times 6 is 12. This side is just 15x minus 58. Okay, so I would subtract the 8x from both sides. 15 minus 8 is 7x. And then add the 58 to both sides. Okay, 58 plus 12 is 70. Dividing by 7 gives us x equals 10. Okay, so they want the measure of angle ACL. ACL is this angle I started with. 4 times 10 for x plus 6 gives me 46 degrees. Okay, so as you're working on these examples, on these problems, you're going to start by identifying which kind of angle it is, and then looking at which formula you should use. Okay, and that finishes this lesson.